Thank you very much, Peram. I would like to start by thanking TechnoBiz and you for the professional way of organizing everything and taking care of all the details and the technical issues required. Highly appreciated. I would also like to thank Brian for putting us together, as he always does in his very nice and gentle way, and very efficient, and for all his assistance and good advice to me and to Levgum. Him and his associates have advised us very good and very valuable advice, which I appreciate very much. He has never spared, in a nicely manner, I must say, his criticism when it was required, and that helped us to be much better. And thank you, Brian, for the kind words. I would also like to thank Nadu for joining us, Mr. Tirone Dumaran, who has been also a long-time friend working for Sundam Industries, our most valuable licensees in India. And you will hear from him, and thank you for taking the time. I would like to thank you, the audience, for taking the time to join this. We will deal with Levgum, and then Nadu will present 2 case studies. Any question, as Peram said, will be answered at the end. And with that note, we will continue. That, okay. So Levgum, in the nutshell, just to put it all wrapped up, has developed the world's leading rubber devulcanization technology, turning rubber recycling into an industrially proven, commercially viable, environmentally clean enterprise. And I want to elaborate on that. First, you have to understand that devulcanized rubber is always less good than the virgin rubber it came from. This is a true statement. It holds everywhere. That is the situation. However, it is not so less that you cannot use it and make money over it. And we have shown that first, you have good properties that you can implement quite a lot of the devulcanized rubber into your virgin compound. Second, that the process can be carried out day in and day out on industrial scale. And this will be shown in later movies that we showed during that presentation, that it's commercially viable, economically viable. That means that you can make money out of that. On a slightly funny note, you know that everybody wants to be green and preserve the environment, but actually count the greens under the table, which is the dollars, and money is green. And this is a joke that only Jews can tell, because Jews harvested it premature. So this process has been proven to be commercially viable, environmentally clean enterprise. That means that we have not swept the problem under any carpet. It is clean all the way through, and I will come to that as well. In brief, Levgum was established through the project of incubators that was developed in Israel back in the end of the 90s and beginning of the 2000s, when we got about 20% of Israel's population coming from the former USSR, who has collapsed and came to Israel. Developed what we call ecological devulcanizer, which is a white powder that you will see. I will refer to it in the presentation as EDV. That is a chemical modifier used to produce what we call devulcanized rubber compound. Now, this is a very crucial point. What we sort of give back is the entire compound. It's not the rubber. Think of it in the following metaphor that can be extended very long further. You baked a cake. The cake got dry. You made out of that cake cake crumb. We give you a patent to make this cake crumb back into dough again, not flour. Flour is the equivalent of the rubber. It will be dough, the flour and the eggs and the oil and the sugar and whatever tastes that you have put in, that will all come back. The same here. We give you the entire compound with the rubber, with the carbon black, with whatever additives that were added and are left. It's simply opening the sulfur-sulfur bond, as you will see. The company is doing its business by selling licenses for use of its technology. Okay, that's what we do. We do not do the devulcanization by ourselves in each and every place because there is no point in that. There is a point in having a local licensee in every territory. The resulting DRC can be a substitute for virgin rubber compound, and I emphasize it's the compound, uh, from 90% in mats to tires. And in tires, I don't really know the amount because the tire companies that I will talk to have never gave me that information. They view that as their secret. And the cost of DRC is approximately 50% of the virgin rubber. So if you can replace 50%, you still save 25% on your raw material, and that's a lot. Thousands of metric tons have been and are being produced every year for the past 15 years using Levgum's technology. The recycling process has to start with something. You have to start by rubber waste collection. If you don't have rubber waste collection, you cannot start. This is something we have not done, but it needs to be in place. Then you need to have a facility to shred, grind, and classify the rubber, to put it into granulates and take out the metal that is sometimes there or the fibers that are there. This is a technology that we had nothing to do with. It has been invented a long time ago, and it is being implemented by many around the world. And then when you have the rubber crumb, it comes to our devulcanization process, where you take this crumb and you devulcanize it to make it workable as rubber again, and then mix it with virgin rubber compounds of all kinds to produce all kinds of products. We will show that in a movie right now to show you the entire process from A to Z. Here you see lorries coming with end-of-life tires, a lot of them of various kinds. This end-of-life tires go into a facility aimed to shred, grind, and classify this. And it does so using various machines that we have not contributed to. This is an existing facility which has nothing to do with Levgum at that stage. This is where the sacks of the rubber crumb comes about in big bags. Then you add the EDV, that's the white powder that I told you, okay, into this. This is a pilot plant, so we pre-mix a little bit by hand. You will be able to see that automatically later on. And it goes 20 times through the roller mills. It has to go past a roller mill with a certain nip and a certain friction ratio for 20 times. Once this is done in an ambient temperature, and as you can see, there are no leftovers, there is no sewage, there is nothing left, nothing emitted, nothing. It simply goes 20 times, and after 20 times, you got the rubber devulcanized. That is DRC. Here is the DRC ready for use. You take that DRC, you ship it as it was before, you ship it to a plant that makes compounds. This is an industrial plant that makes compound, and we are making a compound with 70% DRC. 70% is the black DRC in here. The rest is some chemicals that you see here, another DRC bag, and another one, and a little bit of virgin rubber at the amount of 30%. All goes into an internal mixer, a Bambury. The Bambury temperature goes high. You see the sulfur is getting in one shot, and everything goes in. And what you will see is that it comes out, and we show that it goes through the entire process of zigzag machines, of calendars, of rollers and everything without any problem. There is no intact, there is no torn apart issues, nothing of that sort at 70% level. And this compound that you see here, which looks like regular rubber, includes in it 70% of devulcanized rubber done by Levgum's method. It runs through the entire facility, everything that needs to be done. This is one of the largest one in the United States, Vulcan in the state of Tennessee. And it goes into making mats. You see that the parts are being cut and then they are being placed into a mold. Okay, here, and that's after molding, and we got that, and we have a mat with all the pattern, with everything, a mat that is made of 70%. We've been able, due to R&D, to go to 90%. Thank you. So this is so that is the way to show that it goes from A to Z, all the way through, and shows that you know, the rubber gets devulcanized and can be used in a nice way. In a schematic form, it says take the rubber granulates, take 3% by weight of EDV, the white powder, process it 20 times, and you get a cost-effective solution for that. The advantages, first of all, it's green. It solves the problem of discarded tires. It saves on CO2 footprints by saving energy in producing new virgin compounds that you need. And it's a process that is done in ambient temperature. There is no heat involved and nothing. Remember, rubber has a huge heat capacity. It swallows all your dollars into that. No waste, no sewage, no gases, as you could see on the movie. EDV is also a green manufacture. It is done as a solid state chemistry with no issues, made of off-shelf chemicals that are being produced in tens of millions of tons around the world anyway, so we have not done anything bad. We have been tested by ARDL, the Akron Rubber Development Laboratory in the United States. Anyone who wishes to see can go to Levgum website and see the test results. The DIK, the Deutsche Institute for Caoutchouc Technology, Goodyear, TVS, various parts in TVS, those that are doing regular tires, those that are doing solid tires, and it's TVS, you have to understand, is a large company established in 1911 in India, probably the largest two-wheeler manufacturer in India. Also, Sundaram Industries, which is a daughter company in TVS, produces a lot of solid tires. We've been tested by Pirelli and approved for use in their tires. We've been supplying through our Indian licensee to Apollo Tires, to JK Tires, and many more around the world. It is an industrially proven process. Just Sundaram Industries has been making so far tens of thousands of metric tons over the period that they've been a licensee. And it is gold because it saves a lot of money and can make a good business for the licensee as well, as you will be able to see shortly. We made a cost estimate of what does 1 metric ton of DRC variable production cost is. And we are very conservative in what we are saying here. For example, taking $230 for rubber waste is way too high, but we wanted to be conservative. Levgum contribution, we know exactly. We have just recently, especially for this one, I've ran through the electricity costs around the world. We used to have here $50. We now updated it to $110 because electricity has gone up also in India and in Europe in a tremendous way. So we updated it, and it's slightly over $500 right now, including human resources at a level of Western European or American standard of pay grade. That is a conservative estimate. If you take that conservative estimate and you go through a method that we have developed, that is a method of taking a two-stage approach to this, which is a pilot, by which you make a pilot facility and you invest in marketing and laboratories, because marketing and laboratories are connected. This is a technical sale from the licensee to the customer. He needs to understand how it's done. In order to do that, you need to have our licensee, you need to approach the market and to start convincing the people. We are asking for just a purchase of EDV, not for a per se license fee. We want the commitment by purchasing in advance raw material that will be used in the first year, if customers are there. That will give us the licensee commitment, but will not give us to get rich on his expense, but rather from his success. And the second stage, you make a 10,000, for example. It can also be slightly smaller, 5,000 or higher. But we took the example of 10,000 metric tons a year plant. That will cost you, fully automatic and everything, $3.5 million, plus another $500,000 for marketing and laboratories, plus the 1.2 that you have already invested. In total, $5.2 million worth of investment to do that. That has to be there. We found out that if the licensee does not have that amount of money to start with, he is bound to fail. He is bound to fail because he will hope that he will be able to raise the money later on. He will not be able to do that. He will get stuck in the middle. It happened to us. It happened to us in North America. It happened to us in Brazil. And we don't want that to happen anymore. So we are asking each and every licensee of ours to go and make sure that they have at least that amount of money to start with. Then what happens is, if you combine that, and I'm sure that Nadu will support me on this, you can make at least $250 when selling it for $800, the DRC, still giving a very good margin to the licensee and a very good profit to the end user. Production of 10,000 tons, okay? And that I'm emphasizing, and I put in here these three stars. Licensee's challenge is to do the marketing and sales required in his territory. The reason that Levgum does not build these factories all over the world is that we do not know how to do marketing and sales in each and every country. Marketing and sales in Russia are different than marketing and sales in Japan, which are different than marketing and sales in India, etc., etc. I do not claim, neither does my team, to understand the entire business atmosphere and thing all over the world. Therefore, we ask to have licensee. What we can promise is that once you got to have these 10,000 metric tons worth of sales, then your investment is recouped in less than 3 years, slightly more than 2 to be exact, but in less than 3 years, which makes it a very, very lucrative business, because ROI time of less than 3 years, or say 2 years, once you've been able to hit the numbers in the market, is excellent. It's very good because profit margins are good because of the high margin between the cost of production of DRC and the cost of virgin rubbers today. Licensee. Main benefit to licensee is the fact that we have created something that is a win-win situation for us and for him. The more he sells, the more money we do. We do not take money if he doesn't create the necessary sales, because what we gain from the licensee is the money that we get for selling the EDV. If he does not need EDV because he did not sell DRC, we don't make money. So we are in it together to win together. Therefore, we have all reasons and all motivation to support our licensees, to help them in their sales in anything that we can. We have done that with all our licensees. I've been to India numerous times, sat in panels, gave lectures, went to clients, to potential clients, everything. Who is the potential licensee? The potential licensee can be a granulator of rubber that for now is making 50, maybe $60 on as profit margin on 1 metric ton of crumb rubber that he produces. We are giving him the opportunity to make 250, 350 maybe, if he takes out what he is making on a metric ton. So we are increasing his profit margins dramatically. Rubber compounders who can supply their customers with a good new compound at a lower price. That means that they can either charge the client more and still give him the same properties of the compound that he is asking for, or split the profit between him and them, giving him a lower cost compound, making money on the difference themselves, because there is a huge margin. There is at least $500 to $1,000 worth of margin between what they will sell him using DRC and what they will sell him without DRC. That can be split and everybody can win and make money on that. Rubber good manufacturers are always a good licensee because they have a good amount of waste. Whenever you mold rubber goods, you get an abfall, what they call, which is the leftovers that are vulcanized, and you have to pay to get rid of. You need to pay money to get rid of these not good or leftovers, not good products or leftovers. Instead, you can take them and make them back into raw material that costs you much less than virgin raw material that you would have to take. That is a very good deal for any rubber good manufacturer that is doing molding. The last but not least, any recycler who wishes to enter the field of rubber recycling and make products that give him a high profit margin. Usually, the market of recycling doesn't enjoy high profit margins. Here, the good thing about Levgum is that we gave a good profit margin to everyone. I'm always being asked about competition. And instead, if you go now and Google devulcanization, you will find Levgum, but you will find thousands of other technologies claiming for devulcanization. So I don't think that's a good way of going through each and every one of them. But what I would like to do is to give you a few questions to use as stones of merits in testing and validating which rubber recycling or rubber devulcanization technology you would like to choose. Okay, so first question, is this technology currently on industrial scale? Because a lot of them are on laboratory scale. One way to find out, you ask, can you supply us 200 metric tons a month? You ask Nadu later, he will be happy to supply any of you, listener, or any of you potential licensees, 200 metric tons a month, starting this month, not even next month. So the answer for that by Levgum is yes. Is this technology economically viable? As I've expressed before, yes, it is, and we know that for a fact because our licensees, and we have one online, Nadu, that you can talk to, will vouch that it is economically viable. Has this technology been tested in high performance end products such as tires? Yes, we have been tested by Apollo tires, by TVS tires, by JK tires, by Pirelli tires, and approved by all of them, and they used our material. Is this technology indeed environmentally friendly all the way through. Yes, we have not swept the problem. When we make EDV, we make it out of off-shelf materials that are done in ambient temperature, in solid state chemistry, no leftovers, no sewage, no emissions. When we make with the EDV, the DRC, again, as you have seen, this is a dry process, no sewage, done on ambient temperature, no emissions, nothing. What is the business model offered? Levgum is offering a business model of licensing, that is to do that by the licensee in his own territory, whereas you might find other technologies that are making the devulcanization themselves and sell you the end product. Of course, that has a lot of influence on the profit margin, has a lot of influence on the costs due to logistics and logistic costs, so you have to consider that. What is the expected ROI time and what is it based upon? Levgum is saying it's less than 3 years and it's based upon known costs, variable costs of production and known profit margins that have been done for years. You can now see the devulcanization facility in Pondicherry by Sundaram Industries. And in this slide, we will also be able to see it in work and see the production, how this is really done. Here you can see one machine out of a few. In this place, you can see the rubber crumb mixed with the white powder, goes back with an elevator. Is another machine, goes back by this elevating conveyor. Okay, the second batch is already in place with the EDV and the crumb in it. This one goes through back and forth for 20 times. You see here that it goes down to the back conveyor, having magnets here to take out if there are any metals left. It goes back all the way to the roller mills here. You see the other machines. It goes into the roller mill here. The roller mill is water cooled. The rubber goes in. Once it's done after 20 times, it goes up by a bucket elevator into a silo. And from that silo, it goes into sacks. And you can see that this is an entirely industrial process made with not a lot of human labor. And you see that it's all relatively automatic, called Seal Deck by TVS. Thank you. And with that note, I will say thank you all for your time.